In this lesson, we're going to take a little closer look at the inheritance concept and see what additional tools the Java programming language provides. Let's consider the Zoo2 project. Here is the main class of that. It has a main method which creates an instance of the zoo class. That's this one. Inside the zoo class we have an array of animal object called animals. The contents of that array are a sheep, a lion, and a zebra. Then when we have created our zoo object, we call z.visit. And we go to take a visit to the zoo, print out a message to that effect, and then we iterate over the contents of that animals array and visit each animal in turn. Then we print out that we're going to feed it, and we feed it, and we print out that we're going to pet it, and we pet it. So each of these animals is a subclass of this base class called animal, which has a feed method and a pet method, and then the individual animals like lion override that feed and the pet method and provide their own behavior. But what does an animal actually look like? It's not really a thing, is it? It's more of a concept. You wouldn't see an animal running around in the wild. You'd see a particular animal, like a lion, a sheep, or a zebra. Java actually allows us to express that. It turns out we can mark the animal class as abstract. So we can say public abstract class animal. The first thing that this does is to actually prevent us from ever creating an instance of an animal directly. So if we go across to our zoo class and we were to attempt to add into here new animal, we'll see that we get an error out of that. Zoos animals animal is abstract and cannot be instantiated. Well, that's actually quite a good thing, isn't it? Because it wouldn't make any sense. What would it look like? So that allows us to prevent ever creating an instance of that. Well, this idea actually goes a little further. Because if we think about it, what would it mean to feed an animal? Just a generalized animal as opposed to the specific feeding of a lion or the feeding of a sheep. Well, it turns out we can take this idea a little further, and we can say that although an animal can definitely be fed, it makes no sense to feed the abstract concept of an animal only to feed the concrete specific animals, the lion, the sheep, and the zebra. The way we can do that is we take out the body of the method, we replace it with a semicolon, and then we add this keyword abstract again into the method. We can do that for both of these. Abstract, and then remove that and replace it with a semicolon. We'll save that, and we'll go back to our main class. You'll see there are no errors, no complaints anywhere, and if we run it, it does exactly what it's always done. So everything still works, and it's not a problem to implement our zoo as an array of animals, even though animal is not a real thing, it's just an abstract concept. Now there is a feature of abstract classes that we haven't gone into detail on. That is that they do not have to have abstract methods. They can have as many or as few real methods, and as many or as few abstract methods as you like. They can have variables for storage too. So if there's some behavior in the generalization that is concrete and shared, you can put that right there once in the abstract base class, and all the specializations will inherit that behavior automatically. Java actually allows us to take this concept a step further. Sometimes a class is entirely abstract with no variables and no concrete methods, only abstract ones, just like our animal is at the moment. In that case, it might be appropriate to turn the class into something called an interface. An interface is really just that, an entirely abstract class with only abstract method declarations and no variables. So let's go ahead and make that change. We'll change this class to be public interface animal. So we lose the keyword abstract and class and replace it with interface. Now for each of these subclasses, we no longer say extends animal, we say implements animal. And we'll save that one, and then we'll replace here. save it again, and replace here, and save it again. Notice everything else is happy. We still have our overrides. We still provide the concrete method here. And animal is happy. Lion is happy. And the zoo class is happy. So if we run this again, we see that we get the exact same behavior we got before. So why interfaces? Well, recall that we were only allowed to have one parent class. It turns out that Java does allow us to implement multiple interfaces. So if we want to describe our lion as being an animal and being carnivore, that's fine if both animal and carnivore are interfaces. Actually, either one of them could be a class, just not both. You can extend one class and any number of interfaces. So as a final thought, we've created toString methods on classes and labeled them as @override. But the classes that we did that to didn't have any extends in them. So what parent class method were we overriding? Well, it turns out that if we don't say extends something, we're automatically made a subclass of a special class called java.lang.object. And that's the class that has the toString method that we've overridden. So in this lesson, we looked at abstract classes and interfaces. And we saw how we can use those to provide specializations that don't necessarily include any or even all of the behavior as concrete implementations.